Welcome everybody. Thanks for joining. Today I will present our WindSim webinar, how to develop the right wind power project, a big data CFD approach. Today, first I will introduce you a bit on some context about our screening solution. To then give the word to Jan, who will present, who has agreed to present you some of our real case where he has been using our CFD screening solution. And then I will talk into more details on our screening with WindSim, how to do screening with WindSim. So first, I would like to present myself. My name is Pablo Duran. I'm project engineer and developer at WindSim. And our invite speaker is Jan Olav Oderud. He's project developer in Vindir. So I will let him to present himself better once it's his turn to present. So here what I'm showing now is the typical time span or lifespan of a wind energy project development, where we have the engineering, which is kind of all the planning, due diligence, and so on. Then the construction, and afterwards operation. Per today, WindSim software is mostly used in the engineering part, specifically into the micrositing of rather developed projects. However, as a consultancy team, we offer services that span on the complete lifetime of a wind energy project. And in particular today, we will be focusing on the site screening. So the question is, how can we obtain better prospects utilizing WindSim screening services? I hope that after the presentation today, you can have a good impression of how we can do this with WindSim. So first, I would like to explain a bit of the motivations of why we prefer to use CFD modeling for screening. The first benefit is that we can have an early identification of high wind spots. In other words, we can obtain more pronounced extreme values, which is higher maximums or lower minimums, which actually can be seen in this small example that I have prepared. So here I'm comparing two wind maps. On the left hand, we have one map obtained from the NVE, or the Norwegian Energy Directorate, which is a 1 kilometer resolution map. And on the right hand side, we have a WindSim map of 100 meter resolution. And even though the pattern in general looks similar, how the wind is distributed in the site is similar, we see that the higher winds spots are much more prominent, and also the spots of low wind speeds are also much easier to visualize. So this means at the end, as a project developer, two key benefits. The first one is you will obtain higher annual energy production, which means a healthier financing of your project, because you are able to get where the wind is blowing actually stronger. But also this higher definition of the distribution of the wind will provide you a better information when it comes to deal with landowners. You will have a better information to whom you should deal with, but also how much value actually this site has for you. Another important aspect of our solution is a better consideration of the terrain, and actually this falls more into the CFD part of our solution. And here I'm showing us a small study made in 2014, where it's comparing 50 sites, which is comparing CFD results against linear models, which is kind of the most used models in the industry right now. And we see that we can confirm one of the well-known facts in the wind industry, which is in complex terrain, CFD is better than linear models. But it's not only in those situations, but also in all kind of terrain, CFD models can obtain better results. And so, as I said, so CFD modeling is key in complex terrain, but also we can have a better modeling when it comes for flat terrain. As a project developer, at the end, this means a more realistic energy production, and again, better information with landowners. This time is not about exactly on the higher wind spots, but it has to do that you will be able to take into consideration neighboring terrain or neighboring obstacles that will affect the wind resource map in a certain location. So now we'll give the word to Jan, and yes, please, Jan, the floor is yours. You have to unmute.
Thank you, Pablo. Thanks for inviting me here. I have had a pleasure to work with the WindSim team now over a period of time. And the background for that is the establishment of the company Winder. Winder is a relative newcomer in the product development market space in the Nordic market. We are active in both Sweden and Norway, and our business model is to develop smaller wind projects on cultivated land. Cultivated land means industrial zones next to a highway, maybe agricultural land, managed forests, and so on. We want to develop projects where there is less conflict and close to consumption. When we started, our aim was to do a big data approach so that we better identified the right projects initially. We know that projects that are on cultivated land is also close to where people live. And when we know where people live, we also know where conflicts can arise. For all of us, the NIMBY effect is well known, and we want to try to reduce that. So the big question is, how do we choose the right location initially and not start with one location and fight our way through despite it's not the best and optimal location in the neighborhood. Topographical maps are available in every market, and that defines the modeling. And if I get the next slide, Pablo, access to grid is also an enabler. The access to grid defines the business case as the distance to it and the capacity within it is determining the cost of connection. So we believe that conflict-free wind is close to grid, but close to grid is also where people live, right? So in the map here, we import in a GIS tool where all the registered households are. And why is households important? Well, among many things, noise is a common problem in an NIMBY discussion. So we simply just start with making a buffer zone around any household there is in the area. And as you can see in the gray area, these zones will then be excluded for our development. Then the big question is, who owns the land? And in both Norway and Sweden, this is public info. You know where the borders are, and you know you can easily find who owns any piece of land in the country. Another thing that is reducing and can increase conflicts on product development is cultural heritage sites. So for us, we have a binary approach to it. Is there a recorded cultural heritage? We just exclude it. right? Environmental exclusion zones are a no-go for us. And for Norway, this is different in Sweden, but in Norway, a municipality is allowed to define zones that are very important for recreational activities. It is, of course, so that you usually find someone anywhere that thinks that this particular spot is extremely important. But by starting on excluding those areas that are predefined as important, you can also reduce tensions. And then, as you all know, wind power is powered by wind. So the big question is, where do we find the best wind? And most markets that I have involved with has their own wind atlas. This one is for Norway and developed by the authorities, or paid for by the authorities. And as you can see, the map and its resolution doesn't provide much guidance on where to go. It basically says that this is a windy area. Please place the turbine anywhere. So, but luckily, we have now better tools. The Global Wind Atlas is one of them. There is multiple other sources, but as you can see here, the one colored map in previous slide is now divided and give further guidance. The average wind speed over a smaller area is better suited to pinpoint the right location. As for Sweden, I've seen that these maps are the maps that are used by any developer. We wanted to move further, and therefore we approached WindSim on the matter. And as you can see, with the WindSim tool, we are able to get what we would call a three-dimensional high-definition wind map over our area. I have done product development for the 2 past decades, and usually the wind resource was largely unknown, and the details of it was something we had access to firstly after a completed campaign. Now we have a wind map with the same or a high granularity in an early phase that allows us to pick the better locations. So as you see here now, with the layers that we have discussed, the topography, the landowners, the households, the grid, the cultural heritage, the recreational areas, the environmental zones, you all of a sudden have a map that have a lot of info on where conflicts are. And as you can see here in blue, we then have defined an area where you have high wind and lower conflicts. And this would not have been possible unless we had access to the tool and the consultant services that have been provided by WindSim.
Thank you, Jan, very much for your presentation. Happy to hear to see this example. I think it's a very nice case, and it's very impressive the work you have done so far. So I will now actually jump into more details of how we do this screening with WindSim. So I think it would be good to also show on I will shed some light on the quality and also how it compares with other options that you can find publicly. So the first, I will give you an overview of our procedure. We start from wind data. Actually, the actual name is mesoscale wind data, but you can think of this as just wind data that you can publicly access. And in this case, is we use the one from the new European Wind Atlas, which has the coverage in Europe. I will elaborate a bit more on that afterwards. But then we have a filtering of this data. So this is kind of the big data part. We need to find a way to make a good use of the enormous amount of data we obtain from the wind from this other source. And once our filtering is completed, we can combine it with our wind flow simulation technology and then create at the end a wind resource map. So the first step is to do the simulation. We used a fixed grid and simulation setup. This helps for have a more streamlined and faster obtention of results. And our resolution is 100 meter, and we provide an effective area of results for an area of 24 times 24 kilometers. The actual simulation area is a bit longer, but where you can use the results is this 24 times 24. And this means 2 million cells. So it's for people who are familiar doing this kind of simulations, this is not a heavy setup. Second step is to obtain the data. We download the data from the European Wind Atlas. It has a coverage for the complete Europe. It has wind data every 3 kilometers, which in this 24 times 24 area that I was talking before, means that you will have around 200 points within our model. 10 years of coverage and of time coverage, and vertical levels from 50 to 100 meters. So then the key part of our screening is in this step 3, which is the filtering of the data. So as I was saying before, we had about 200 points per site. So this is many points. You can see in the image in the left hand side, we have a map, and these white dots represents where we have wind information for the wind. And the problem is that we have many points, but some of them are very good. So we can have error of almost negligible error, which is quite impressive. However, some other points are really bad, which means you can have errors on the order of 20 meters per second. And of course, we have everything in between. This means that if you just randomly pick any of these points, you might not get the worst, which is 20, but you might get 3 meters per second or 2 meters per second, and this is an important deviation in our estimation. So then we need a way to obtain the good points. So how can we choose these good points? And this is something that the WindSim consultancy team has developed, which is an in-house methodology, which is based on 3 principles. So we choose points where the terrain is similar in our CFD model and also in the European Wind Atlas dataset. We look at the terrain complexity. So we look for places where the complexity of the terrain is rather low. And finally, and probably one of the key aspects of our method, is that we look for points where the predictions do agree to each other. And this is a very important step. So if you just only do 1 or 2, you might get rid of the worst points, but you will still have some points that are not that good. And adding this third step, then we completely choose the best points. And I will have here prepare a case where I compare different sources. So this particular area is located in the southern west coast of Norway. I have put this picture on top of the area, the landscape of the area. It's a beautiful area, but as you can see, it's very complex. You have some hills around, a lake, and you can. This is not the particular location where the measurements are, but the area in the surroundings are pretty much like this type of landscape. And I have compared 4 products. So first we have the WindSim that we have been talking so far, which is based on CFD and has a resolution of 100 meters. Then I also compare with the European Wind Atlas microscale dataset. So the one that I was talking before is a mesoscale dataset This one is a microscale dataset. You can also find it in their webpage, which is based on WASP. And this one has a 100-meter resolution as well. Then we have the Global Wind Atlas. John talked quickly about this. It's also based on WASP. Actually, it is using the same methodology as the NIWA. And it has a resolution of 200 meters. And finally, I have the one from the Norwegian authority, so the Norwegian Energy Directorate, which is not using a microscale model. It's just a mesoscale model like NIWA actually, but it has a resolution of 1 kilometer. And I have compared based in two metrics. The first one is bias, and basically it's telling me if the modeling approach is over predicting or under predicting consistently. So if a value is close to 0, it means that it's doing either of those. But if it has a positive value, it means it is over predicting most of the time. And if it has a negative value, it means it's under predicting most of the time. And we can see that under this criteria, our solution is performing much better. The European Wind Atlas microscale actually is using as an input the same inputs that we are using. The main difference is how we treat this input, this big data that we are obtaining from the NIWA dataset, and how we introduce it in our simulation. So this is kind of the intelligence of what we are doing, and we can see kind of this reflects in the results. And even though we have a similar bias, our bias is better, but there's the one in NIWA is not that bad. However, if we look at the root mean square error, which in a way is just the real feel of the error that you will see when you're evaluating a project, we see that we have a huge distance. So NIWA is not constantly over predicting, but it is giving ups and downs. It's a very scattered predictions, while we have a much more consistent solution. Yeah, I will not elaborate more on that. Finally, we just did also validation at other locations as well. We have working with 17 validation points, 11 met masts. We have assumed, just for the sake of the exercise, we have assumed a 2% of uncertainty, and then 6 wind turbine data. These actually are not 6 wind turbines. These are 6 points, which it's a group of wind turbines of maybe can be just 1 turbine or 4 turbine at most. So each of these groups define 1 point. So you can see here that this is we can compare the measured wind speeds compared to our predictions. And in overall, we see that a rather small bias are very good bias for a screening tool. And also this is reflected in the root mean square error. Okay, so some conclusions on our presentation today. Well, first, a proper early modeling of the wind resource is key for the development of your project. If you don't have a good modeling, high resolution, high quality, your project will just not be developed. It will impact in your early financing, and also it will impact in the decision making of choosing to which landowners you will talk with, and so on. So it's very important. And what we can offer as a WindSim site screening is high quality wind maps, which will mean which are substantially better than other public sources. Is CFD based, which means that better information which you negotiate with landowners, and streamlined procedure, which means you will get timely results. So if you have more questions or we are interested in this service, please reach out our consulting team in this at consulting@windsim.com. Dee and myself will be the ones in contact to provide you this service.
Okay, would like to thank everyone for your attention, and also to Pablo and Jan Olav for the educational presentation. And now we're going to go into the Q&A session. And so far, I can see we have at least a couple of questions here. So the first one is, I will ask to Jan Olav. Are you with us, Jan Olav?
Yes.
Yes. Do you specifically map each feature with buffer by yourself in GIS software, or do you access data from any external databases?
My old professor learned me that any good answer starts with "it depends," and it really depends on what country you are developing projects in and what data you have available. I have been active in some 15 different countries throughout my career, and the access to data is very different depending on what part of the world you're developing projects. But the need for data is the exact same regardless. When it comes to buffer zones, which was a very specific question here, it is, I guess, a reference to distance from households. And in Norway, we have that on public records. When I do this in, for instance, South Africa, we do this automatically based on Google Earth pictures, and then we make rules on setting distance from observed points. I am not a GIS expert myself, but in ArcGIS you have a lot of features for this exercise.
Thank you, Jan Olav. Sounds like a good answer and thorough one. So I would like to remind everyone to use the Q&A feature in the Zoom software. So we're going to move on to the next question. And we have a question here as follows. How fast is it to model a wind farm? Siting, optimization, and prediction of the wind resources on site.
Well, that's for you, Pablo.
Yeah, I think so. I will mostly focus on the speed of the modeling part, because that's kind of the purpose of this service. So as I mentioned in the before, and actually I think I can also show you a little bit on that. The type of configuration we use in the gridding is relatively light. As I said, 2 million cells. Of course, this will depend on your computer, but in a computer that you use in the office, which is not like a supercomputer, it's just like a 3 gigahertz CPU. We can obtain results in a couple of hours. So this is a relatively fast approach. Of course, this is not the same level that we would use in a final or a more mature wind resource assessment, but we see that this is an effective way to have good results and also in a good time. Remember, it's always a trade-off between quality and time. And we have found that for this purpose, for the level of uncertainty we're generating, it's a good approach. So it's a quick enough approach and with enough quality.
Thank you, Pablo. And we have another question. Are there any tools to directly import NEWA data to WindSim? No, there is no directly ways to do this. And the problem is basically, the format, and also the application. The only application we have now is kind of this service. And we have been mostly all the automatic tools to download data are focused in Mera 2, or also we are now looking into ERA 5 to have it there. And the reason we have those instead of NEWA is that those are widely used for long-term correction. But this doesn't mean that we will look into implement it as part of the software. But of course, as part of the service, we do it ourselves with our own scripting. Very well. Do you apply a weighting scheme for different information layers during optimal site selections?
I guess that's for me. So how my most recent experience was that we mapped a total of 63,000 square kilometers with this methodology, where we used it. Well, in theory, we did it binary. We had, you saw in my presentations that we had some 10 different layers presented. There can be other layers also, which is more specific to national interest. I have eliminated them, but we basically did a site identification based on binary criteria, meaning that if there was one constraint, we eliminated the area. And on this most recent exercise, on the 63,000 square kilometers, we ended up with some 140 theoretical available zones. And how we did it then was that we took and had a workshop with the different experts on ranging them. I mean, I don't think you can fully digitalize this. It is more a guidance for how the experts can have dialogues as you go. So, but again, this is a product of what data you have available in your specific location, right? How accurate is it? How many layers can you actually produce? I do not think that you will ever end up developing a project without visiting the site first. My point with this methodology is that we can more proactively range and identify what landowners to reach out to, and especially when you are developing closer to cultivated land, which was the term we used. It is extremely important that you know where to go first.
Thank you, Jan Olav. This one, it goes to Pablo. Which CFD turbulence model do you think is the best in assessing the effect of forest canopy distribution on the mean flow? I have used LES only, but I was wondering if other models are better.
Yeah, that's a hard question, to be honest, to answer. I can just tell you more from the perspective of the experience in the literature. And of course, the more is the best, in the sense that we have on the CFD aspect, we have on the low end or the lowest complexity in the modeling part or the turbulence part, you would have these one equation models that you can find also in the market. And then we have the two equation model like WindSim. WindSim is not the only one actually that can provide this type of modeling. And I would say that that's kind of the limit in terms of quality versus speed. So there are better models like LES, as was mentioned, but at the end it has to do with how much time you can wait, basically. So there's some products that they have LES, but it's quite a rather limited space.
Nice. And we also have another question here, I guess is for you, Pablo. What is your opinion about hybrid RANS/LES turbulence model in complex or moderately complex terrains? Did you get it, Pablo? You have to unmute.
I had to read it.
Yeah, that's understandable.
No, I have no experience with hybrid RANS/turbulence models, to be honest. Most of the experience that we have had is with RANS, two equation turbulence models for RANS.
But at the end, it has to do with, as I said, as this trade-off between how much you can spend on time and how much you can get in quality marginally. Yeah.
Yep. Good. And we have more questions. That's great. Would you say that the efficiency of the model change if we consider a smaller area than 24 by 24 kilometers, keeping 2 million cells constant? Is bigger area better, or is it the other way?
Yeah, that's a good question, because at the end has to do with the quality of results and depending on the configuration. So if you keep the 2 million cells constant and make a smaller area, basically you're trying to increase the resolution. I guess that the question goes in that aspect. And effectively, you might have a higher resolution, which might mean that we'll get a better or higher quality results. However, you must consider that you will have border effects. All CFD models have these border effects, and actually, if you remember, you see from the slide, the simulation area actually is 44 times 44, and the reason that we keep it that kind of the simulation area is bigger than the area where we test the results is because in the border you have you have lower quality because of these border effects. And so making the area smaller, keeping the same number of cells, you might have higher quality, but still you have to take into account that you need certain distance from the border. That's kind of my main point. So yeah, that's kind of that's basically the trade-offs you should think about when designing your area.
Great. I have a question for Jan Olav, and it goes as follows. In your experience, is 100-meter resolution adequate to decide where to develop a project? Are lower resolutions sufficient, or even higher resolutions necessary?
I mean, the paradigm shift we have now when it comes to wind resources is that we can make high resolution wind maps. What WindSim is providing is the best I have seen in the market. And I think the slides that I showed on the wind resources, when you show the granularity, you find you first get the value of that when you are seeking small lots of land. Cultivated land is also, as I said, described by being close to where people live and work. But in most countries, I would also say that the average size of a land lot is way smaller in those areas than in the more scarce populated areas. So what are you seeking? Well, you are seeking to cost efficiently develop a project. And if you can interact with fewer landowners, you save time and you increase your turnaround time. So for me, us and Winder, it is important to cherry pick the very landowner that we want to target and eliminate the other ones. And if you take this very picture that is shown to you now, you see that with more details, you can actually cherry pick the one landowner that owns a very small piece of land. So back to the question, to the resolution, it is a product of how small the land lots are mostly. If there is only big pieces of land, you have to have a deal with the landowner regardless, and then the granularity is less defining the costs of your development.
Thank you, Jan Olav. And we have one more question for Pablo. And that is, let me scroll through here. Did you compare performance with WindPro?
No, we haven't compared performance using WindPro for this, but I know WindPro uses linear models, and this is kind of comparable to what we have seen the results in WASP. And I think in this case, this comparison would be less critical, because since we are using quite a streamlined configuration, we are not so worried about speed. It's already quite fast, our procedure from obtaining the data sets up to you get kind of the final wind map. However, I would like to insist that most of the magic, even though of course we're doing CFD modeling, there is a lot of effort put in the data treatment in advance. So there is a lot of engineering in that part as well. And that's kind of part of what we wanted to communicate as well. Like, we have put a lot of effort in making a validation study and try to make this as smart as possible, but also as automated as possible.
Okay, that was, as far as I can see, we have no further questions. So I would like to thank everyone for attending this WindSim webinar, and also a big thanks to Pablo and Jan-Olov for answering all the questions and the educational presentation. And we hope to see you at future WindSim webinars. So thank you so much for joining, and have a nice weekend. Bye-bye.
Thank you.
Bye-bye.
Bye.